All right, so in this video, we're going to go over the distance formula, and we're going to use it specifically to tell which point in a problem like this is point A closer to P or is it closer to Q. So we're going to actually use the distance formula a couple times in each of these examples. Okay, but anyway, the distance formula is the distance between any 2 points is going to be the square root of the difference of the x coordinates to the second power plus the difference of the y coordinates to the second power. Okay. Now it's really irrelevant if you label the a coordinates as x1, y1 or x2, y2. Same goes for b. Order here is irrelevant because the squaring is going to end up making this difference positive in the end anyway. Okay. When you square a negative, you get a positive. When you square a positive, you get a positive. Okay. So the order here is irrelevant. Okay. So we just want to make sure we plug these orders in, these coordinates in. Into the formula. All right. So in example A here, we've got point P at 1, -2. We've got point Q at 8, 9. And then we've got point A at 5, 3. So let's go to the graph real quick and look at where those points are. And then we'll come back and show the steps for the distance formula. All right. So I've already plotted the points here. So we had point P at the location 1, -2. We had point Q at 8, 9, and we had point A at 5, 3. Okay, so if I connect those points, okay, then I've got a line from P to A, and then if I connect A to Q, I've got another line there. So you really can't tell by looking which one of those is closer to A. It looks like it's going to be pretty close, okay? So we don't want to use the look test anyway. We always want to show and prove our work algebraically in this case. So let's go back to the Word document and we'll go through the steps to determine which of those points is actually closer to A. All right, so first thing I'm going to do is find the distance from A to P, to point P, okay? So let's plug in our value. So I'm going to plug in the x's first. So I'm going to start with point A. I'm going to do 5 minus 1, okay? And then I'm going to do 3 minus the y coordinate -2. Okay, so notice this is the difference of the x coordinates to the second power, and then plus the difference of the y coordinates to the second power. Okay, so 5 minus 1 is going to be 4 to the second power. 3 minus a -2 is 5 to the second power. So this is going to be 16 plus 25, which is the square root of 41. Okay, it's not totally necessary to convert this to a decimal, but I'm going to do that anyway. So square root of 41 is approximately equal to 6.40. All right. So now let's find the distance from A to Q. So this time I'm going to plug in the coordinates for A to the distance formula and the coordinates for Q to the formula as well. So difference of the x coordinates, so I'm going to do 5 minus 8. Okay. Then I'm going to subtract the y coordinates from one another, 3 minus 9. Okay. So 5 minus 8 is going to give me a -3 squared. 3 minus 9 is going to give me a -6 squared. Okay. So when I square a negative, remember we're going to get a positive here, so it's going to be 9 plus 36, which is 45, okay? So you can just tell by looking at these that the square root of 41 is going to be less than the square of 45. But again, I went ahead and converted those to decimals for you anyway. The question is, which of the 2 points is closer to A, okay? So because the distance from A to P is less than the distance from A to Q, therefore I know that A must be closer to point P. All right, let's look at the next example. All right, so I'm actually not going to graph B here. It says draw the parallelogram with vertices A, B, C, and D. I'm going to let you guys do that on a coordinate plane. Okay, so plot those 4 points. All right, and we want to use those 4 points to help us kind of determine the area of the parallelogram. So before you do that, let's talk about a couple things. Reminder, the area of a parallelogram can be found using the formula A equals base times height. Okay, so we need the base of a parallelogram and we need the height of the parallelogram. Okay, so you can count the length of the base because the base is going to be a horizontal. From A to B here is going to be our base. It's on a horizontal, so you can count that distance. All right, you can count the height. Okay, you can count the length of the height because the height's going to be on a vertical. Both of the bases are on the same horizontal. So that means the height is going to be the vertical line from one base to the other. Okay, so you're going to be able to count both of the length of the base and the length of the height. So you're not going to need to use the distance formula here. Okay, and once you've counted the base and once you've counted the height, you multiply those two together, and that'll give you the area of the parallelogram ABDC. ABDC. Okay? All right. Let's look at the last one, part C. So in part C here, we're going to want to use the distance formula here to determine is C closer to E, okay, or is D closer to E. So let's go to the graph and look at those points, and then we'll come back and show the work. All right, so I've already plotted the points here for you. So C is at -6, 3. D is at 3, 0. And E here in the green is at -2, 1. Okay? So if I connect those, okay, I've got that line CE, and I've got the line from D to E. All right, so again, these look really close. I can't tell which one's closer. So I'm going to have to do the distance formula and work out the steps and determine which is actually closer to E. Okay, so let's go back to the document. All right, so let's break down the steps here. I'm going to do C to E first, so the distance from C to E. All right, so let's plug in our x coordinates. I've got -2 minus a -6, so -2 minus a -6. And then I'm going to plug in the y coordinates, so it's going to be plus the difference of 1 and 3. Okay, so this is going to be -2 plus 6, which is going to be 4 squared. This is 1 minus 3, which is -2 squared. Okay, so 4 squared is 16, -2 squared is 4. So that gives me the square root of 20, or 4.47. Okay, now I could simplify this to 2 radical 5, but that doesn't really do me any good here. We're just going to compare the radical version or the decimal version in the end. Okay, all right, so the distance from D to E. So let's plug in our x coordinates. I've got -2 minus 3. Okay, when I plug in my y coordinates, I get 1 minus 0. Okay, so -2 minus 3, that's a -5 squared. 1 minus 0 is 1 squared. Okay, so -5 squared is 25. 1 squared is 1. If I add those together, I get square root of 26. Okay, so again, you can just compare these radical versions here. You get square root of 20 and square root of 26. If you need the decimal version, fine, okay, but you don't really need it. So it's easier to, this number is obviously the lower of the two. So that means that C is going to be closer to E than D was, okay? So that's how you use the distance formula to determine whether one point is closer to another.